Welcome to this video on cybersecurity fundamentals, focusing on IAM integration in cybersecurity. We will take a deep dive into definitions, architecture, cloud integrations across AWS, Azure, and GCP, automation, and real-world scenarios. We begin with Section 1, Foundations, focusing on understanding identity and access management, or IAM. IAM is a framework of policies and technologies that ensures the right users have the appropriate access to technology resources. The key goal is simple: the right people, the right access at the right time. While cybersecurity is a broader discipline, encompassing network security and threat intelligence, IAM is a critical subset. IAM focuses strictly on identification, authentication, and authorization, managing the entire user lifecycle. IAM is fundamental to the CIA Triad. For confidentiality, IAM prevents unauthorized access. For integrity, it tracks changes via audit trails. For availability, IAM systems must be highly available to prevent operational lockouts. The core components of IAM include identification, who are you? Authentication, AuthN, prove it. Authorization, AuthZ, what can you do? Finally, accounting or auditing, what did you do? Moving into Section 2, how IAM works, we will review the mechanics, architecture, and identity lifecycle. The user identity lifecycle consists of 5 key steps. Provisioning sets up the initial access, followed by authentication and authorization. Regular review of permissions is critical, concluding with deprovisioning upon departure. Authentication methods fall into 3 categories: something you know, like passwords, something you have, like a token, and something you are, like biometrics. Multi-factor authentication, or MFA, combines 2 or more of these for enhanced security. The 2 main authorization models are role-based access control, where permissions are assigned to roles, and attribute-based access control, where permissions are determined by policies evaluating user, resource, and environment attributes. Single sign-on, or SSO, provides unified access, letting users authenticate once for multiple applications. Federation extends this trust across different security domains, simplifying access across various corporate tools. Section 3 addresses the modern security paradigm, IAM and Zero Trust. The core tenet of Zero Trust architecture is straightforward: never trust, always verify. The 3 pillars of Zero Trust are identity, requiring explicit verification and strong authentication; device, validating device health and compliance; and network, using microsegmentation to limit the blast radius of any breach. Section 4 focuses on Azure integration, specifically Microsoft Entra ID, formerly known as Azure AD. Microsoft Entra ID is a leading cloud-based identity and access management service. Key features include seamless integration with Office 365, connectivity to thousands of SaaS applications, and syncing with on-premise Active Directory for hybrid environments. Azure Conditional Access works by evaluating signals such as user, location, and device risk. Based on these inputs, it makes a decision, such as allowing access, blocking access, or requiring MFA. Azure RBAC roles define permissions within a specific scope. For instance, the owner role grants full access and the ability to delegate access, while the reader role allows viewing existing resources without modification. Section 5 covers AWS integration and the use of AWS Identity and Access Management, or AWS IAM. The core elements of AWS IAM are principals and policies. Principals are the users or roles accessing resources. Policies are JSON documents that define the permissions granted to these principals. The AWS policy JSON structure uses key elements like effect, which can be allow or deny, action, specifying the operation like S3 list bucket, and resource, defining the specific AWS resource being acted upon. AWS IAM best practices include locking the root user, using groups for permission assignment, using roles for services instead of storing credentials, enabling MFA for privileged users, and always enforcing the principle of least privilege. Section 6 will focus on GCP integration, specifically Google Cloud Platform IAM. GCP uses a resource hierarchy where policies are inherited downwards. This hierarchy moves from the organization root node, through folders, into projects, and finally down to individual resources. This image illustrates a hypothetical cloud identity market. GCP's implementation of the Zero Trust model is called BeyondCorp. It shifts access controls from the network perimeter to individual devices and users, enabling secure work from any location without a traditional VPN. Section 7 covers live scenarios, demonstrating practical applications of IAM in real-world situations. Scenario 1 is automated onboarding. An HR trigger creates an account in Entra ID. Birthright access is assigned automatically, and role mapping grants specific application access based on department. Scenario 2 illustrates impossible travel. If a user logs in from London and then Tokyo minutes later, IAM detects a velocity anomaly. The system automatically responds by spiking the risk score, blocking access, and triggering a password reset. IAM has a major impact on overall security posture. Section 8 explores automation, specifically using PowerShell scripts for IAM administration across different platforms. In Azure Entra ID, the Microsoft Graph PowerShell SDK is used to manage cloud users. This allows you to connect, retrieve user information, and create new cloud-only user accounts programmatically. For hybrid identity management, on-premise Active Directory still uses the Active Directory module. PowerShell enables tasks like unlocking accounts, adding users to security groups, and finding inactive users for cleanup. AWS IAM automation uses the AWS tools for PowerShell. This enables you to list all IAM users, create new ones, and attach specific policies, such as read-only access, to users for streamlined management. A common automation scenario is bulk onboarding. A PowerShell loop can import CSV data from an HR feed, generate passwords, and automatically create user accounts in the system. Section 9 looks at the challenges and hurdles encountered during IAM implementation. Two key challenges are user friction, where complex login flows lead to MFA fatigue, and shadow IT, where employees use unmanaged apps, creating significant security blind spots. Looking toward the future of IAM, the perimeter is shifting. Passwords are becoming the past, and identity is the new perimeter that must be secured. Decentralized identity, or Web3, introduces self-sovereign identity. Users own their data, and blockchain integration is used to verify credentials without relying on centralized identity providers. Thank you for your attention to this video on IAM and cybersecurity.